Alright, what's up guys? In this video we're going to build some calculus here, and we're going to do some more implicit differentiation. So we're asked to find dy dx, or dy over dx, and we're given here x plus 2x is equal to the square root of y. So for implicit differentiation, remember what you do is you differentiate both sides with respect to x, and then every time you differentiate y, you multiply by dy over dx. So basically what you're doing here is trying to solve for dy over dx. And really the only calculus that is involved in this is just taking the derivatives at the beginning, and that's pretty much it. It's just solving equations after that, trying to isolate the variable. In this case, which is dy over dx. So let's begin by doing that. And I have done plenty of videos on implicit differentiation, so this one is a little bit more involved, so this probably wouldn't be a good one to look at for your first time, but I do have videos on easier ones. So if you would like, check those out if you can. So we'll start by differentiating both sides with respect to x. So the question is, well, what do we get? Well, it looks like we'll just get 1 plus 2 times dy over dx. And that's going to be equal to dy over dx divided by 2 times the square root of y. That's what you get when you differentiate both sides. Okay. The next thing I'm going to do is subtract 1 from both sides. So if I do that, I'll end up with 2 times dy over dx is equal to dy over dx divided by 2 times the square root of y minus 1. And again, the goal here is to solve for dy over dx. And pretty much what you're trying to do, and what we're going to need to do, is get dy over dx over on this left-hand side here, the equal sign. Because once we get both dy over dx's on the same side, we can end up factoring one out. So that's pretty much the goal. But there's a little bit of work that needs to be done beforehand. So the next thing I'm going to do is I'm going to go ahead and multiply both sides of this equation by 2 times the square root of y. That'll get rid of that 2 times the square root of y on the other side, such that we can actually subtract it away. So we'll have 2 times the square root of y. So that'll be 2 times the square root of y times 2 times dy over dx. And that's going to be equal to this side, which is dy over dx divided by 2 times the square root of y minus 1. We'll multiply this side by 2 times the square root of y. And if we do that, well, it looks like we'll just end up getting 4 dy over dx times the square root of y is equal to dy over dx minus 2 times the square root of y. And the reason why we had to do that, there was just no way that we were going to be able to get, we needed to get that dy over dx over 2 times the square root of y. We need to get it out of that fraction form, because we need to get this dy over dx over here. And certainly, I mean, we could have subtracted, dy over dx divided by 2 times the square root of y from both sides, but I don't see where that would have helped us. So what I did was I just went ahead and multiplied both sides by 2 times the square root of y, and that just basically got rid of it. So that now we got the dy over dx sitting over there alone. And the goal is to get it over here. Okay. So that's the goal. Okay, so again, now we're going to do is we're going to subtract dy over dx from both sides. And we see what we get when we do that. So here's what we got. We got 4 times dy, 4 times dy times dy over dx times the square root of y minus dy over dx is equal to dy over dx minus 2 times the square root of y minus dy over dx. And what does that do for us? So again, it'll just give us 4 times dy over dx times the square root of y minus dy over dx is equal to what looks like we'll be left with negative 2 times the square root of y over on this side. And now notice how we have both dy over dx is on this side now, which is really what we wanted. So let's divide both sides by, well, actually we need to factor out a dy over dx first. And we factor out a dy over dx, we can then just divide both sides by 4 times the square root of y minus 1. So let's factor out a dy over dx. So if I factor one out, I have dy over dx, and it'll be 4 times the square root of y minus 1 is equal to negative 2 times the square root of y. Now you can always check whether or not you factor something out correctly by distributing it back in. So you ask yourself, okay, if I distribute back in the dy over dx, do I get back what I got there? And yes, I mean, if you do that, distribute back in, we'll have dy over dx times that. We do get that. Dy over dx times 1, minus 1 will give us that. So you did factor it correctly. And now we'll divide both sides by 4 times the square root of y minus 1. So, put in parentheses, 4 times the square root of y minus 1. So we divide both sides by that. And we'll clean it up a little bit. Okay, so it looks like we'll have our dy over dx over on that side isolated, which is fine. But what we'll end up with is on the right hand side is 2 times the square root of y all over 4 times the square root of y. I'm sorry. Write it this way. Sorry. Negative 2 times the square root of y all over 4 times the square root of y minus 1. That's what we'll have over on the side without the equal sign, or on the right hand side of the equal sign. So this is what we got. Four times the square root of y minus 1. That's what we got on that side now. Okay. But let's clean this up because we don't want square roots in the denominator. That's typically going to be a big no-no. So the way to get rid of that is by multiplying by the conjugate. Just go ahead and multiply both the numerator and denominator by the conjugate of this denominator, 4 times the square root of y minus 1. So let's go ahead and multiply that. So we'll multiply that by 4 times the square root of y plus 1. And again, the whole goal here is to get the square roots out of the denominators. Some professors are really big on that. So I just try to not give them an opportunity to take any points away. So if we do it in the denominator, we got to do it in the numerator. So we'll multiply by the conjugate of the denominator, which is 4 times the square root of y plus 1. And that's going to be divided by 4 times the square root of y minus 1 multiplied by its conjugate. So what we're doing is rationalizing, basically, times the square root of y plus 1. And what that will give us, and we'll go ahead and write our final answer. We'll kill 2 birds with 1 stone. We could say that dy over dx is going to be equal to, I'll bring the negative to the side. It's going to be equal to 2 times the square root of y multiplied by 4 times the square root of y plus 1. And that's going to be divided by, if we simplify down here, well, we'll get 16y minus 1. And the goal there, again, is to get the square roots out of the denominator. Just take that extra step. So don't give the professor any chance to take any points away. So that's your answer. And that's how you do implicit differentiation. So again, maybe not a good example for the first. I do have some easier ones, so check those out. But that's going to be it for this video, and I will see y'all next time.